Good day, grade 12 learners. Welcome to today's mathematics lesson. My name is Mr. Shongwe, and this lesson is brought to you by the Gauteng Department of Education in collaboration with the Hyperbola Discovery Center. Right, today we are looking at the revision for paper 1. Remember, good people, we are writing tomorrow, so we need to be ready, okay? In our revision, we are going to be focusing on the heavily weighted topics. You can see it is functions and differential calculus. The reason why we are working on these sections is because they weigh more than any other topics in paper 1. Hopefully, you've done all the other topics, including the 2 that we are going to do today, and this will just serve as a reminder of the things that are important and crucial in the revision session, or rather when you're going to write tomorrow. Right, you can see here we're still on mark distribution and target setting. Okay, hopefully by now you have checked and you have traced whether you are reaching your target per topic. Okay, if in case there's a topic that you are not yet reaching a target for, it's not too late. You can still prepare that topic and prepare it thoroughly so that you can be able to reach the target there. Okay, you can see algebra and equations. It's 25 with a variance of 3, 22 to 28 marks. Patterns and sequences, 22 to 28 marks. Functions, it's 32 to 38 marks. Finance, 12 to 18 marks. Calculus, 32 to 38 marks. Probability, 12 to 18 marks. So you can see the topics that we'll focus on, they weigh more than 45% of the paper. So it's more than 45% of the paper. But it's also crucial that you get those marks on algebra, you get those marks on patterns. When it comes to finance, I would actually conscientize you as far as this section is concerned to say, even if the question, you can see that the question maybe is a bit complex, you cannot respond to it, please do not leave space there. Okay, it's important for you to know within that particular statement that is given whether it is a compound and whether it is a future value annuity problem or it's a present value annuity problem. If it's a present value, you choose the correct formula there, and there should be attempt of substitution. You know, when you are given the percentage there, you can obviously convert that to a fractional interest rate, and also you can look at the number of payments. Okay, those are things that would give you marks there. All right, even if you are not able to solve the whole question, but once you've identified that it's a future value or a present value annuity, you need to go and substitute the fractional interest rate, substitute the number of payments. But very important, use your timeline there. The timeline is going to assist you to ensure that you get those marks there. All right, now you can see if you are looking at this just for passing. All right, if you want to just pass, all right, a minimum pass, okay, you can look at these targets that we've actually set out for you just to get a minimum pass. Okay, if you check, and these marks are attainable in any exam. It is marks that come from accessible content. All right, and then you can see they add up to 67, and you only need 45 marks to pass. All right, let's take this on. Remember also, we are available on our WhatsApp interactive number 079-578-2908. You can ask any questions on our WhatsApp line. Questions should be based on the lesson that is ongoing. Okay, please make sure that you interact with us, you ask those questions, so that by the end of the lesson, at least you'd have gained a lot for you to be able to write tomorrow. Your teachers have done a very good job in preparing you for the exam. We are just here to finalize everything that you've done with your teachers. Okay, let's look at the lesson objectives. By the end of this lesson, you should be able to revise functions and inverses by focusing on exam type questions. So we are going to be zooming into those exam type questions. Revise differential calculus by focusing on exam type questions. That's basically at the center of today's lesson, but our calculus would go until the cubic functions. We are not going to have enough time to touch on the aspects of optimization. All right, obviously there is the information sheet there, very useful. Okay, we will be using this a lot today because we deal with the first principle. Okay, but you can see there are formulas here. These formulas here, they speak to sequence and series. All right, sequence and series, and these are formulas here that speak to finance. Okay, finance, growth and decay. All right, growth and decay. It's not always money. Sometimes they can tell you about population. All right, population growth. So you need to be able to utilize those formulas. And you know, these two here, they are for what? For annuities. It's also part and parcel of finance. It's annuities. That's what you do in grade 12. All right, please make use of the formula sheet. The formulas are there to be used. All right, can see this side you have equations here mostly that are working in paper 2, and then also you have equations here for trigonometry that are working mostly in paper 2. Remember, topics can be integrated. You might find an integration between, say, sequence and series as well as trigonometry, where they give you the sequence in terms of what? In terms of trig ratios. All right, sine 90, 2 sine 27, and so on. So they give you that sequence in terms of the trig ratios, which means that your knowledge of special angles, your knowledge of trig there also plays a role. So you cannot divorce some of these sections together. They can integrate sections in paper 1 together with sections in paper 2. Nothing is stopping them from doing that. All right, now let us look at the concepts that are examined in functions first. But first and foremost here, it is the sketching of all algebraic functions. It's important. The first thing that you need to know about functions is how to sketch them. Very important. So you need to know how to sketch a straight line in the form y is equals to ax plus q, and also the parabola in the form of ax squared plus bx plus c, or in the form of y is equals to a into x plus p squared plus q. That is the turning point form, and this one is the intercept or the dual intercept form. Okay, so both these are standard equations. Okay, both of them are standard equations, but the other equation is in turning point form, the other one is in the dual intercept form. All right, and then you have the rectangular hyperbola in the form a over x plus p plus q, and then you have the exponential function in the form y is equals to a times b to the x plus p plus q. All right, so now you need to then also be able to sketch all the inverses. We know for a straight line, the inverse there is given as ax plus q. For a parabola, we know that the standard graphs that you need to look at is ax squared, and then for exponential, you know the graph that you are going to be looking at here, it's a to the x there. So these are the standard inverses that are studied in our curriculum, right? Now, the domain and the range, the asymptotes, the turning points, the intercept, the line of symmetry, increasing and decreasing nature of each function, that is also important. Interpretation as well, this is also important. So this gives you the umbrella of the examinable concepts in functions, all right? I want us to then zoom into the interpretation and see what points of interpretation of functions that we need to know, that we need to learn and understand, okay? Now, these are just the basic characteristics. We know all the functions would have the x and the y-intercept. Some would not have an x-intercept, like usually your exponential functions, all right? Some of them have the x-intercept, but most we find that, especially those that are in the form y is equals to a to the x, you find that they do not have x-intercept, okay? And then the turning points are applicable to second degree functions or the parabola, and then the axis of symmetry, the line that cuts the graph into two equal parts, that is applicable in hyperbolic functions as well as in second degree functions. And then asymptotes, a hyperbola, we know it has asymptote, the line that the function should not intersect, all right? And then from there we have the exponential functions. They also have asymptotes. We do have here both horizontal and vertical asymptote, all right? But here you only have the horizontal asymptote. Only have the horizontal asymptote, right? And then you have the domain of all functions and the range of all functions. That is just the basic characteristics, that every function would have these characteristics. Not all right? Some characteristics are only unique to specific functions, all right? And then now we look at interpretation. Very, very important. These are points that you need to actually understand as far as interpretation is concerned. Determining the equation. Sometimes the function is sketched and you need to reverse it and determine its equation. That's very, very important. Horizontal and vertical lengths. At times they ask you to determine the length. The horizontal length, we know horizontal distance, that should be x on the right minus x on the left. And then you have the vertical distance, which is y top minus y bottom. And then you have the diagonal distance there, where we are going to use what? The distance formula. x2 minus x1 squared plus y2 minus y1 squared, okay? That is the diagonal distance. But horizontal distance, x on the right minus x on the left. Vertical distance, y top minus y bottom. And then the diagonal distance, we use the distance formula, right? Increasing and decreasing functions. Remember, a function will increase when an increase in x values is associated with an increase in y values, and it decreases when an increase in x values is associated with a decrease in y values. Also, we can talk to the increase and decreasing nature of the function using what? The gradient. If the gradient of a tangent at specific points in that particular function is positive, then the function is said to be increasing. But if the gradient of a tangent to any point in that specific function, all right, is negative, then we say that the function is decreasing on that region where the gradient is negative, but it increases on the region where the gradient is positive. Like for an example, if you have a cubic function, all right, a cubic function, you can see if we are saying that this is x is equals to a, and this is x is equals to b. You can see from left to right, as I move from values that are less than a, all right, as I approach a there, you can see that the gradient of a tangent here is positive, and the gradient here is negative. The gradient here is positive. So when the gradient is positive, we say the function increases. So this function will increase for values of x that are less than a, and also for values of x that are greater than b. So that is where the gradient is positive, and that's where the function will increase, okay? And then where is it going to decrease? The function will decrease where the gradient is negative. That is when x is trapped between what? between the value of a and the value of b. That is where the function will then decrease. That's where the gradient is negative. So those are things that you need to know. The point of intersection, we know to find the point of intersection, we are going to be equating the two functions that we are working with, right? That's where the x and the y values are common in the function. So we work with f of x equals g of x if the first function is f and the second function is g. Remember here, this is the same knowledge that you gained in what? In algebra. Remember our functions there, our functions are using the knowledge of algebra. When we did algebra and we did all those things, inequalities, simultaneous equations, solving for x and all of that, we did that because we knew and appreciated that later you will have to use this information in all the other topics. That is why the first topic in grade 10 and grade 11 is algebra, because we know and appreciate its role in the whole syllabus of maths, okay? So just like here, we are applying the knowledge of simultaneous equations to solve inequalities in functions for which values of x is f of x times g of x greater than 0. You see, those are inequalities. We know and appreciate that we did the algebraic form of inequalities in algebra, where we are going to solve them algebraically. But here, in the context of functions, we don't bring along algebra. We are going to be interpreting using what? Looking at the graph that is given. So we interpret and we solve these inequality questions using the graph, not using algebraic methods. And transformations, you know, at times when we talk to transformations, we are talking about reflection, all right? We are talking about translation. All right, reflection, it happens in the x-axis. It also happens in the y-axis. But when you look at translation, it happens horizontally and also happens vertically. All right, that is translation. So we reflect and we translate, and at times we have the horizontal stretch and the compression of the graph. Okay, so the average gradient between 2 points, remember the average gradient comes from the fact that the gradient is y2 minus y1 divided by x2 minus x1. That is the average gradient. And then we also have the nature of the roots, but using the graphical approach. We are not going to be using the discriminant here in the context of functions, all right? I think we've said a mouthful as far as the approach to functions is concerned. Now let us look at exam type questions and see how best we can respond to those exam type questions. All right, that is the first question, is on the interpretation of a hyperbolic function. All right, the function h of x is equals to a divided by x plus p plus q is sketched alongside the lines x equals 3, y equals minus 2 are the asymptotes of h. P, which is a point 4, maps -4, is the point on h. Now, when you look at this, the equation is not given, which means that we are actually looking at this particular thing here, all right? We are looking at bullet point number 1, determining the equation of all functions that are sketched. In this case, the sketched function is a hyperbola, all right? So the first question says determine the values of P and Q. All right, the second question, calculate the value of A. So you can see those are the parameters that are on what? That are on the equation. So that's what is expected of us. And then number 3, the coordinates of the y-intercept, okay? Number 4, the domain of the transformed graph, okay? So that is transformation now. Number 5, the line of symmetry. So it's all the things that we've been talking about that we said are important points as far as basic characteristics of functions are concerned, as well as also the interpretation of functions concerned. All right, now let's look at the solution sets here. If we want to determine the values of P and Q, remember we are going to be looking at this and say x plus P is equals to 0, which implies that x is equals to negative p. All right, so we already know the axis of symmetry. Remember, this is the asymptote, not the axis of symmetry, the asymptote. Already we know what the asymptote is in terms of x. It is given by what? X equals 3. So we know that our 3 is equals to negative p, which means p would be equals to what? Negative 3. What about q? We know from here that the value of y is equals to what? Q. Already we know the value of y is negative 2, which means that we have negative 2 is equals to what? Q. So Q is negative 2. So that's how you work this out using what? Using the given asymptotes, all right? So we get that P is equals to negative 3. I've already taken you through that, as well as Q is equals to, Q should be negative 2, all right? This has a mistake here. Q should be negative 2 based on what is given there, all right? And then calculate the value of A. Calculate the value of A. Let's check now. Since we have the value of P and the value of Q, we can come and substitute them into the original equation, and then from there we substitute the additional point, which is given as what? 4 and negative 4, all right? Then we calculate the value of A. So you can see we've substituted the value of P, which is negative 3. We've substituted the value of Q, which is negative 2, all right? That is why I said there's a mistake there. And then we've substituted X and Y, all right? Because we are given the point P. So we've substituted, that was Y, and we've substituted X, that was 4, all right? So y is negative 4, x is 4. And then from there, we solve for a, all right? We get that a is negative 2. If we check here how we solved for a, we said negative 4 is equals to a divided by 4 minus 3. That is 1 minus 2. Transposing the 2 there, we get negative 4 plus 2 is equals to a. So a becomes what? Negative 2. So that is where we got our negative 2. So here you are going to get a mark. Here you got a mark for each. All right, so you get your 2 marks there. And here you are going to get a mark for substitution and get a mark for the answer there. So that would be 2 marks as well. All right. Now let's move on to the next question. Calculate the coordinates of the y-intercept. You know, when you want the y-intercept, you have to equate x to 0. So let's check here. Okay. First, we substitute all the parameters because we have all of them, all right, so that we get the equation of the function. And then from there, we are going to say for the y-intercept, we put x to be equals to 0. We know y-intercept, we put x to be equals to 0. So where there is x, we put 0 and then we solve. When solving for that, we get that h of 0, all right, which is the y when x is equals to 0 is negative 1 and 1. It's negative 1 and 1 over 3. So it's negative 1 and a third, okay? So we get that the y-intercept would be 0 as well as negative 1 and a third, okay? Right, that is how you work out the y-intercept. I think so far so good. Everyone is following. Everyone is able to do this, all right? Let's go on. Remember, if you are not following and you have questions, please do interact with us on our WhatsApp line, all right? Now, write down the domain of g if g of x is h of x plus 2. Remember, the original function has a domain of what? Since we know that our h of x, we said it's negative 2 divided by x minus 3, and then we had that to be minus 2. Let me just verify there on the previous slide. Yes, it is minus 2 divided by x minus 3 minus 2. Remember now, the original domain here, the domain of h, the domain of h is x an element of all real numbers, but x cannot be equals to 3. Okay, that is the domain. Now, what has happened here? The graph has undergone what? A transformation, all right? The graph of g is obtained when there is a transformation of what? X plus 2 equals 0, which means x is equals to negative 2, which means that all the points on G are going to be moving, or rather the points on F will move, or the points on H will move 2 units to the left, so that we obtain all the points on G. All right, so we can then be able to then determine the asymptotes here, or rather determine the domain, because we are going to say the domain would be translated by 2 units to the left as well. All right, so that's what we do there. If you translate that by 2 units to the left, you are going to say its x cannot be 3, so 3 minus 2, all right, which gives us 1. Okay, alternatively, what one can do is you can apply the transformation to the function. All right, if you apply the transformation to the function to get the equation of g of x would be equals to negative 2 over, where you see x, you put x plus 2 minus 3, and then minus 2. So this would be negative 2 divided by x minus 1 minus 2. So what would be the domain? Domain of what? Of G will then be x, an element of all real numbers, but x cannot be equals to what? The asymptote, which would be 1. So it's the same as what we got there. All right, so we are going to get 2 marks there. 1 mark for being able to apply the transformation to the original domain. All right, now the last one, E. If the graph of H is symmetrical about the line y is equals to minus x plus c, determine the value of c. So already here you have that the line is symmetrical. This is a symmetrical line, so which means if we can substitute here what the asymptotes, because x and y represent the asymptote, and we know that our asymptotes are x is equals to, oh, there they are, x is 3 and y is negative 2. If we can substitute them there, then we'll be able to obtain the value of c. All right, that's what we are going to do here. All right, we substitute x with negative 3 and y with negative 2. We get that c is equals to 1. Okay, let me go back again. Alternatively, here you can always also say that we know that this is a reflection of minus x. All right, is a translation of the line y is equals to negative x, but it is translated by p units horizontally, all right, and q units vertically. So this would then be negative, we get that this would be x minus 3 minus 2. So this would be negative x plus 3 minus 2, negative x plus 1. Therefore, c is equals to 1. So that's another way in which you can do it, by applying the transformation to the original axis of symmetry, which is having a negative gradient. That axis of symmetry is y is equals to negative x. If you apply the horizontal and the vertical translation, since the graph has been shifted horizontally and vertically, then you can get the whole equation there. All right, now we are done with the first question on the hyperbola. We are now moving on to the parabola. All right, we are moving on to the parabola and a straight line. All right, so this is a question. Let's go through it. The sketch below shows the graph of g of x is equals to negative x minus 2, and f of x is equals to ax squared plus bx plus c. You can see here that the parameters are not given for the quadratic function, which means we can expect a question that would want us to go back and determine the equation of the quadratic function. All right, a and b are the x-intercepts of f, and c is the turning point of f. A and t are the points of intersection of f and g. R, which is K and negative 3, is a point on G. CR is perpendicular to the x-axis. All right? Determine the x-coordinate of A. Show that K is equals to 1. Hence, write down the x-coordinate of B. And then the next one, show that the equation of f is negative x squared plus 2x plus 8. The next one, determine the values of x for which f of x minus g of x is greater or equals to 0. The last one, for which values of k will g of x equals k have a negative root. So these are questions. The last two, D is on inequalities and E is on the nature of roots, right? I want you to just look at the question, read the question again, all right? I'm just going to give you 1 minute just to read the question again and read the statement and read the questions. And then after 1 minute, we'll come back and then do the solutions. 1 minute starts now. Hello and welcome back. All right, let's look at the solutions to these questions. All right. The first question is determine the x-coordinate of A. Now, if we check here, we are having the equation of G, all right? If you check, coordinate of A is what? Is a point of intersection, is a common point between a straight line and a parabola. So we're going to check, can we use the equation of the parabola to get that x-intercept? Unfortunately not, because that equation is not given, all right? But because it's a common point, it is also the x-intercept of a straight line. We check, do we have the equation of a straight line? Of course we do. So we can find the x-intercept of the straight line. So we are going to then work out the x-intercept of the straight line since we have the equation. So the x-intercept, we put y to be equals to 0. So if y is 0, we have x minus 2. Transposing x, then we get that x of A is equals to negative 2. That is the x-coordinate of A. We are going to get a mark here for substituting, putting x to be equals to 0, and for working out the value of x. So that would be 2 marks, all right? That is the first question, okay? Now, remember with the first question, we said A is the common x-intercept of what? The parabola and a straight line. So we check which equation is given. Since we are given the equation of a straight line, we use a straight line to determine that, okay? Now, it says, hence show that k is equals to 1, or show that k is equals to 1, and hence write down the x-coordinate of B, all right? Show that x is equals to 1, all right? And write down the x-coordinate of B. K is equals to 1, I mean. Now, if you look at this point R, you can see that it's given as what? K negative 3. But where does it lie? It lies on the straight line. So point R lies on the straight line. And already we have the equation of a straight line. So we'll go and substitute on the equation of a straight line x with k, and substitute y with what? Negative 3. All right, so let's check there what happens. So g of x is equals to negative x minus 2. That is the equation of a straight line. Why are we using that equation? It's because point R lies on the straight line. All right, it lies on the straight line. So it will respect the equation or conform to the equation of the straight line. All right, so we substitute. Where we see x, we put k, where we see y, we put negative 3. All right, now simplifying that, we get that k is equals to 1. So we'll get a mark for the substitution here, get a mark for the answer. That is a sweet 2 marks. All right, and they say hence write down the x coordinate of b, which means this question cannot be just for 2 marks. It should be about 4 marks. About 4 marks, okay? Because there's a hence. Show that k is 1, that is 2 marks, and hence write down the x coordinate of b. That should be another 2 marks. Now, if we look at the x coordinate of b, we can see, let me denote here point x, point A and point B here. This is point A, and this is point B. Or let me put B here. So point A, we are given the value of x, or we've worked it out, is negative 2. But we know the axis of symmetry here, which is the value of k is 1. And then we want the value, the x value at b. So the axis of symmetry becomes the midpoint, which means we can use the midpoint formula and say x at the midpoint, which is the axis of symmetry, x at R, all right, is equals to x at A plus x at B divided by 2. All right, why are we doing that? It's because it's the midpoint. All right, the axis of symmetry is always the midpoint between the two x-intercepts. So if we use the midpoint formula, we get that x at R, we substitute, which is 1. X at A is negative 2 plus x at B divided by 2. So we get that now. If we are to solve for this, you need to cross multiply there. We get 1 times 2 is equals to negative 2 plus x at B. And then you get 2 is equals to negative 2 plus x at B. Transposing the 2, we get that x at B is equals to 2 plus 2, which is 4 there. All right, so that is the value of x at B. All right, so you will get 2 marks here, 1 mark for substitution to the midpoint, and the next mark for the answer there. Remember, others can use a translation to say, okay, let me check how many units I've moved, okay, from negative 2 to 1. I've moved negative 2, negative 1, 0, 1. I've moved 3 units. So from 1, I'll also move 3 units. 1, 2, 3, 4. So that is why I have 4 there. So that is how you can also apply the transformation there, or rather, not the transformation, the midpoint, all right, the midpoint formula. If you are saying it's in the middle, which means to move from the axis of symmetry to the left-hand side, would be the same number of units that it will take to move from the axis of symmetry to the right-hand side. So that is why we are using the midpoint formula that we are more accustomed to, that we use in analytical geometry. All right, now the next question, show that f of x is equals to negative x squared plus 2x plus 8. Show that f of x is equals to negative x squared plus 2x plus 8. Now, going back here, you can see we already have the x-intercept, all right? X at A is negative 2 and x at B is 4. So we have that x at A is -2 and this one is 4. So we are given the two x-intercepts, all right? And you can see we are also having an additional point. So to determine the equation of a parabola, if we are given two x-intercepts and a point, we are going to be employing y is equal to a into x minus x1, x minus x2, where x1 and x2 represent the x-intercept, and the fixed variable points x and y represent what? The additional point. All right, they represent the additional point. Now let's go through that one. Starting off, I said we used y is equals to a into x minus x1, x minus x2. Now you can see what we did there. Where we see x1, we substituted -2. So it was, now it's x minus -2, all right? And then x minus 4. So minus 2 gives us +2, all right? Now we need to substitute the additional point, all right? The additional point. What is our additional point? Is 5 and -7. So when we substitute x is equal to, remember our additional point is 5 and -7. So where we see x we put 5, where we see y we put -7. All right. So now can see where we see x we put 5, where we see y we put -7. Now we solve for a. All right. 5 plus 2 is 7. 5 minus 4 is 1. So we get that -7 is 7a, which means a is equals to -1. Now that we have the value of a, we are going to substitute it back. All right. Now when we substitute a back, that's what we get. Then we are going to apply the distributive law to write that in standard form. All right. Now, according to the distributive law, what will happen here? This would be x times x, that is x squared, x times -4, that is -4x, all right, x, all right, 2 times x, that is plus 2x, 2 times -4, that is -8. Remember, all of this is subjected to what? A negative. So if we simplify what is inside here, we will get negative into x squared minus 2x minus 8. If we distribute the negative, the x squared would be negative, the 2x would be positive, the 8 would be positive. So we get the equation as it is there, all right? So that is how we determine that equation, and it was for 4 marks. So our first mark will go to substitution of what? Of the x-intercept. The second mark would go to now substitution of what? The additional point. And then the value of a, then from there, after getting the value of a, then being able to distribute. So we get that this would be for 4 marks, all right? The ability to distribute there. So you get your sweet 4 marks there. So it's important that you are able to do this, all right? Now, let's move on to the next question. All right, let's move on to the next question. Determine the values of x for which f of x minus g of x is greater or equals to 0. Determine the values of x for which f of x minus g of x is greater or equals to 0. All right, now it looks like my function, I was supposed to have my function here. It looks like my function is no longer there. Okay, but it's fine. We will always use the one on the previous slide. So this is f of x. We transpose g of x, we will have greater than or equals to g of x. Okay, let's go back and check here. F of x greater or equals to g of x. It is asking where the graph of, let's check here, where the graph of f is above g, all right? So we want a situation where the graph, or the region where the graph of f is above the graph of g. If you check the graph of f is the parabola, where is it above the graph of g? In this region. The graph of f is above the graph of g. That is where x is trapped between -2 and 4. 4. You can see here, that's where x is trapped between -2 and 4. It should be 4 here, not 5. -2 and 4. So you are going to get 2 marks for your trouble there. All right, it's 2 marks for your trouble there. And then the next question, for which values of k will g of x equals k have a negative root? For which values of k will g of x equals k have a negative root? Okay, now we want to know when this graph will have a negative root. I'll have to go back because there was a technical issue with my graph there. So I want to know where g of x equals k has what? Has a negative root. Now, I'm looking at the graph of g, the straight line. Where, remember, g of x equals k, we are moving a line y is equals to k with respect to the graph, up or down with respect to the graph. And we want a region where this line will be cutting the straight line on the negative x-axis. So when we put the line down here, observe what is happening. It is cutting the graph where? On the positive x-axis. As you move the line up, it is still cutting the graph where? The straight line. Focus on the straight line. It is cutting the straight line on the positive x-axis. When you move the line here still, it's cutting the straight line on the positive x-axis. When you get to the x-axis, check now, it is cutting the graph on what now? It is cutting the graph on the negative x-axis. Now, let's go down y-intercept. Let's check the y-intercept. At the y-intercept, it is cutting the graph at what? At 0 as well as or only at 0, which is not positive and also cannot be classified as positive. But just go above the y-intercept of the straight line. What do you notice? Above the y-intercept of the straight line, the graph now, the straight line starts to cut the graph on the negative x-axis. So it should be above what? The y-intercept of the straight line. Now let's check the y-intercept of the straight line. The y-intercept of the straight line is -2. So it should be above the y-intercept, okay? So the y-intercept, we work it out, we get -2. So we found out that indeed, this straight line, let me check here, this straight line here, it was like this, okay? This was -2 that we just calculated. So if you subject a line, y is equals to k, you can see here that it's cutting on the positive. This is the positive x-axis, this is the negative x-axis. So as you move the line up, when you get to the y-intercept, you can see it is cutting where, what you call, where x is equals to 0, all right? And 0 cannot be classified as positive, can also not be classified as negative. But as you go up, just above the y-intercept, check now, it is now cutting on the negative x-axis. As you go up, it's cutting on the negative x-axis. As you go up, it's cutting on the negative x-axis. So that's where it has what? A negative root. So it has a negative root where k is superior than -2, which is the y-intercept, all right? Superior than -2, which is the y-intercept. Hopefully, you are still with us there, right? Remember, if you still have questions, you did not understand this one, you can always interact with us on our WhatsApp interactive number. I think it's at the bottom of your screen. It's 079 578 2908, all right? Let's move on. Now, this is a consolidation activity that will also include some inverses. All right, if you check, this is for 2, 4, 6, 9, 11 marks. All right, so I want you to do this question. All right, I want you to test yourselves with this question. I am going to give you 10 minutes. All right, just 10 minutes. I want you to try this question out to the best of your ability. And please be quick. 10 minutes is what you have, and your time starts now. Right, hello and welcome back. I hope you were able to respond to this question promptly. All right, let's check. Sketched alongside are the graphs of f of x is equals to 2 to the exponent of x, and g of x is negative x minus 1 squared plus b, where b is a constant. Okay, the graphs of f and g intersect the y-axis at c, so it's a common y-intercept there. D is the turning point of G, all right? Show that B is equals to 2. That's the first question. And then the second question, write down the coordinates of the turning point of G. The next question, write down the equation of the inverse of F in the form y is equals to. Next question, write down the equation of H if H of x is equals to G into x plus 1 minus 2. So this is a transformation, all right? It's a transformation. And then E, how can the domain of H be restricted so that the inverse of H becomes a function, all right? So you can see now we are integrating this with the inverses. Now let's see how best we're supposed to approach this. Show that B is equals to 2. Now if you check you have the y-intercept point C there, which is a common y-intercept. If we can use the equation of f, we can be able to get the y-intercept there, all right? We can be able to work it out, okay? But you can see here, f of x or g of x is negative x minus 1 plus b, all right? So now if we substitute, all right, if we substitute 0 and 1, you see x is equals to 0, y is equals to 1. Where are we getting that? It is point what? Point C. How did we get point C? We said y-intercept x is equals to 0. All right? So we have that now. Y would be equals to 2 to the exponent of 0. So y would be equals to 1, which means that the coordinates of C would be 0 and 1. So that is why here where we see x we put 0, where we see y we put 1. So that is the substitution for 1 mark of 0 and 1, and then the value of then we simplify this to negative 1 plus b transposing that we get that b is equals to 2. All right, b is equals to 2. So you get our 2 marks there. All right, so it might be for 3 marks this question. It's not fair to be 2, it should be 3 marks. The first mark would be for actually working out this point, which is 0 and 1, then substituting it into G and solving to get the value of B. All right, so that was the first question. The next one, write down the coordinates of the turning point. Already you know what B is, you substitute B there. You already had x there, so we know the turning point would be 1 and 2, all right? It should be 1 and 2 because if it's in the form y is equals to a into x plus p squared plus q, x is equals to negative p is the axis of symmetry and y is equals to q. So we have negative p and q as the turning point. So here you'd have 1 and 2 because x minus 1 is 0, x equals 1, that is 1 there, and y equals 2, that is 2 there. So that is the turning point. For 2 marks, obviously, we are going to just have to mark twice here, which is 2 marks there, or we can give 1 mark for substituting it there, but remember ultimately they wanted the turning point. Okay, now determine the equation of the inverse of f in the form y equals to, this is the equation, y equals to 2 to the x. We want the inverse of that. Okay, so what is the first thing that we do? We interchange x and y. When we interchange x and y, we get x is equals to 2 to the y. All right, we make y the subject of the formula. Here we have to use the logarithms here. Log of a number, the logarithms here, to its base is equals to the exponent there. So that is what we then do here to say this is the log base 2 of x, all right? The log base 2 of x, that would be the inverse of f, all right? And then we get 2 marks there, interchanging x and y, as well as writing the equation down, all right, in the form of logarithms, okay? Right, we move on. Write down the equation of h if h, this is a transformation. What is happening here? X plus 1 is equals to 0, which implies that x is equals to -1. You are moving 1 unit to the left, and you also have y is equals to -2. You are also moving 2 units down, all right? So now what we are going to do, we want to write the equation. So we are going to go to g, right? We are going to go, this is g. So where we see x, we'll put x plus 1, all right? And then we will also subtract 2. So where we see x, we put what? We put x plus 1, all right? We put x plus 1. So it will be x plus 1 minus 1. And then we put -2 there. So that gives us h of x is -x squared. So we are going to get a mark for the horizontal translation, a mark for the vertical translation, a mark for the answer there, which gives us 3 marks, okay? And then from there, how can the domain of h be restricted so that h inverse would be a function, all right? How do we restrict the domain of h so that the inverse becomes a function, all right? So this is a quadratic function. We know there's a restriction of what? Of the domain. So what happens is that we have y is equals to -x squared. So this would be the function y is equals to -x squared, okay? Now, if we draw the inverse of this function, if we draw the inverse of this function, we know that now the inverse should look like this. All right. So now if you subject it to a vertical line test, you see that it touches the graph on 2 different points. All right. It touches the graph on what? On 2 different points. So it cannot be a function. So we have to restrict what? To restrict the domain. So how do we restrict the domain? We are going to take this portion of the graph, which is x is greater or equals to 0, or we are going to take this portion of the graph, which is x is less than or equals to 0. So if we are to take that, then we will have only one arm that would pass the vertical line test, okay? So the inverse there becomes a function. So we're going to have that we are taking x is less than or equals to 0, or x is greater than or equals to 0. That is how we can restrict the domain. All right, so that is what we have here for this particular question. Okay, let's see. Now, we are done with the questions on functions, right? We have to then now move to differential calculus, all right? We are now on differential calculus. Let us check the examined concepts on differential calculus. First, it is the average gradient between the 2 points. Hopefully you have that checklist. As you prepare, you are using the checklist to check, all right? To check which concept you've covered and which concept are yet to be covered, so that by the end of the day today, you are confident to say, I've exhausted all the aspects of the checklist per topic and I am ready to write paper 1, all right? So now, the gradient of a tangent to a curve using first principles given the x value of the coordinates of that point, or the coordinates of that point. Also remember the limit concept, all right? The limit concept. Solving questions involving the limit concept, all right? The limit concept is also examinable before you look at what? First principles, all right? Using the rules of differentiation, equation of a tangent to the curve using the concept of the derivative, applying the factor and the remainder theorem to solve third-degree polynomials, sketching cubic functions, as well as interpreting them, the optimization concept, word problems, shapes, graphs, rate of change, and motion. So these are the concepts that are examinable in what? In differential calculus. Let us have a breakdown of a few of these concepts. There are those that we cannot do because of time constraints. But let us see how far we can go with the other concepts there, all right? Now we are starting with the average gradient and the gradient at a point. Now the mistakes that you normally make when you are looking at first principles is the notational errors. If you check the first one here, the person did not put what? F prime of x. So you lose a mark for doing that. Please use the formula as is indicated on the formula sheet. Let's look at this one. This one used what? Two equal signs. The f prime of x is equals to the limit of sh tends to 0, which is equals to, and that is a notational problem, notational error. You lose 1 mark, all right? Please make sure you don't lose a mark for notation. Now, let's look at this one. This one wrote it as one thing. He put the limit as the numerator and h tends to 0 as the denominator. And remember, you are trying to limit the average gradient. You are using the intuitive description of the limit to say we are moving from left to right, okay? As we move from left to right here, what happens is that as the value of h becomes smaller, approaching from left to right, we get that the gradient, the average gradient, gets closer and closer to the gradient of the tangent. So that is why we use the limit concept. So the limit as h equals to 0, that is from what? That is from the intuitive description of the limit. What are we doing? We are limiting what you call the average gradient. Using what? Using the values of h approaching from left to right, and h becomes smaller and smaller, all right? So that is what we are doing here. That is what we should be conceptually understanding as far as the first principle is concerned. Okay, forgetting to put brackets when doing substitution, that comes up a lot. Incorrect removal of brackets, that comes up a lot as well. Dropping off the limit before substituting h equals to 0, that comes up a lot. Substituting h is equals to 0 before simplifying to the equation to its simplified form, that also comes up a lot as far as the errors that you are making, all right? So please look out for that. Now let's look at the first example. Given f of x is x squared minus 4, determine the average gradient of the function between x equals -1 and x equals 3. We are dealing with the average gradient, and it is between what? It is between 2 points. So this is the same gradient that you know from analytical geometry. And then the next one says, determine the derivative f prime of x from first principles. Now, let's look at the solution set here. Let's start with the average gradient, all right? Using the functional notation, we're first going to substitute x equals -1. We feed it into the original equation to get the corresponding value of y. Because for us to calculate the gradient, we'll need our x1 and y1. We'll need our x2 and y2. So here we only have x1, we have x2. So we feed those back to the original equation to get the corresponding values of y, and then we're going to use those corresponding values of y to calculate the average gradient, all right? Now, let's check. First things first, it is the equation. Now, we put -1. We substitute -1. When we feed that with -1, we get that y is equals to -3. So we have a point -1 and -3, all right? Now we want to get the next point there. So the first thing that we are doing, we're determining f of -1, all right? Now we need f of what? F of 3, all right? So now when we feed the function given there with 3, we get that this is 3 squared minus 4, which is 9 minus 4. This is equals to 5. So we can see here that when x is equals to 3, y is equals to 5. So we can use these 2 points to calculate the average gradient, because the average gradient is the gradient between 2 points. Now, obviously, we're explaining there that we were determining f's of 3, all right? So now we go to the average gradient. The average gradient would be equals to y2 minus y1 over x2 minus x1. In functional notation, it is given by what? F of x2 minus f of x1 divided by x2 minus x1. In this case, x2 is 3, all right? x1 is -1. So f of 3 minus f of -1 divided by 3 minus negative 1. This obviously gives us 5 minus negative 3 divided by 4, which means that the gradient is equal to what? 2. That is, the average gradient is equal to 2. So we explained there that obviously we were determining the average gradient. So that's basically where we start with this. Remember, in our examined concept, the first and foremost point there was speaking to the average gradient. That's what we just did now. All right, let's now move to first principles. All right, remember, from first principles we know step 1, we need to determine what? F of x plus h. That is what we need to compute, right? We compute f of x plus h, we simplify it, then we go to the equation as contained in what? In the formula sheet. I don't want any of you to lose marks as far as this is concerned. Remember, the examinable functions in terms of the first principles are ax plus q, which is the straight line, y is equals to ax squared plus bx plus c, which is a parabola. We are also examining y is equals to a, where a is an element of real numbers. The derivative of a constant, it's also examinable in first principles. That is 1, that is 2, that is 3. We can also examine the reciprocal function, y is equals to a over x. This is what was examined in your June exam. Please, most of you did not get this correct. Please look out for that. It's something that you need to know, all right? Also, we can have that y is equals to ax cubed, right? The cubic, we are only taking the leading variable, which is x raised to the third power, all right? Also, with the hyperbolic one, we are not going to have the, to add the value of p and the value of q. No horizontal, no vertical translation. It is the original function, all right? It is the original mother function of the hyperbola. So these are the functions that are examinable. Please make sure you practice each and every one of them, because you may never know what will come up tomorrow. All right, in this case, we're getting one that is in the form of what? Ax squared plus bx plus c, which is parabolic. All right, let's look at that. Now, first things first, we write f of x, then we compute f of x plus h. How do we compute f of x plus h? Where we see x, we put x plus h. Then we simplify, all right? We get that f of x plus h is x squared plus 2hx minus h squared. Now, I want you to do this first, okay? After this step, I appreciate if you were to do this. You were to do this, x plus h into x plus h, because that's what it means if you have a square there, all right? And then from there, I would want you to simplify this on its own, and then minus 4. So that would be x squared plus hx plus hx plus h squared. So that is where you got 2hx, okay? So I need you to do it step by step. It will never hurt you, all right? Doing it step by step will always help minimize the mistakes. All right, now we've computed f of x plus h. We check whether simplifiable. If it's not, we leave it like that. We go straight to the formula for the first principles. Now, let's look at the formula. F prime of x is equals to what? The limit as h tends to 0 of f of x plus h minus f of x over h. Now, what we do here is, since we've computed f of x plus h and we have f of x, we substitute. All right, let's check now. We substituted what? F of x plus h minus now f of x, which we put in brackets. Very, very important. F of x is a binomial. It contains 2 terms. So if you subtract there, the negative must affect everything. Hence, it's important that you use what? Brackets. All right. I will always stress that the use of bracket becomes very, very important. And now what happens is, even if you use the brackets where you were not supposed to use them, you are not going to get things incorrect. But a failure to use brackets where you're supposed to use them, you'll have a problem. So when you subtract and it's 2 terms, please use those brackets so that you see that the negative sign is affecting both the terms that are inside of the bracket. All right, now we can simplify this further, okay? We've opened this, we've distributed here negative x plus 4, all right? Now you can see this guy over here, and this guy would give us 0, okay? -4 and 4 will add to 0. So you can see what remains there. It's 2hx plus h squared divided by h. The limit as h tends to 0 of that particular expression. All right, now we can take out h as a common factor. All right, taking out h as a common factor, we get h into 2x plus h divided by h. Now we put h to be equals to 0. After having divided out, we put h to be equals to 0. We get what? We get 2x. Now where do we get marks here? We get a mark for computing f of x plus h. We get a mark for substituting it. All right, we get a mark for simplifying. We get a mark for taking out h as a common factor. We get a mark for the answer. So this would be a sweet 5 marks there for first principles. Please, tomorrow, make sure you get these 5 marks. All right, now that is example number 1. All right, we've done and completed example number 1. Let's move on to rules of differentiation. All right, rules of differentiation. Instead of always using first principles to find the derivative, which can be quite tedious, you've seen the steps there, right? So we can use the rules of differentiation to enable us to differentiate more complex expressions or functions. All right, we determine the derivative of a function. We also say we differentiate the function. We don't derive. All right, we don't derive. I normally hear you saying, then I derive it. No, we don't derive, we differentiate. All right, let's correct that. It's the correct mathematical language is to differentiate, not to derive. Deriving is something else. All right, the process is called differentiation, and the result is called what? The derivative. So when you differentiate, you obtain what? The derivative, which is referred to as what? The gradient function. All right, so everything that you do when you differentiate, you are working out the gradient function, which is a new function that tells you how the gradient behaves. All right, now let's look at the notation. When you differentiate a function f of x, you use f prime of x. All right, that's what you are normally accustomed to. When you differentiate y, if the function is written in terms of y, differentiate it with respect to x, you use what we call dy dx. All right, dy dx. But when you these two are equations. All right, these two are equations. But when you start differentiating expressions, you use now the differential operator dx of that particular expression, or you use what we call ddx of that particular expression. So when you differentiate expressions, not equations, you use the differential operator, the operator d there, dx, all right? Or you use ddx of that particular expression. But when you differentiate equations, if they are written in terms of y, you use the y dx. If they are written in terms of f or h or what, you use f prime or h prime, depending on the function, the functional notation of that particular function that is given at a time. All right, now we've done the rules of differentiation, the background. Now we need to go and look at how to approach the rules of differentiation. Now, first we need to know notation. I've already spoken to you about the notation. Number 2, all the expressions that must be differentiated must be written in that form for us to be able to differentiate them, because remember, we are using the fact that if y is a x to the n, then we get that then dy dx, this is the basic rule that we use, is a n x n minus 1. All right, that is what we use. Okay, so now that is very, very important. Okay, but if we take away a, we can take away a here, still the same. All right, still the same, even if the constant was there, but let me remove it. So that is the standard equation that we are going to use. So the formulas must be written, all of them, in this form. So that is why we are actually asking you to do that. Now, how do you do that? You make sure that there are no brackets. All right, so if there are brackets, you FOIL, apply distributive law, you open those brackets. There are no fractions. By no fractions here, we mean no x in the denominator. That's what we are referring to when we are saying fractions in the context of this section here. and no root sign. So we have to be able to use the fact that if we are given the nth root of x to the m, to convert that, we get that this is equals to what? X to the m divided by n. So what happens is that the degree of the radical becomes the denominator of the radicand. Okay, so that is what we do to solve that. And then from there, we are having a factorization of both the numerator and denominator in a fraction is key. Sometimes we would need to differentiate, or rather we will need to factorize the numerator, factorize the denominator, so that some of the terms will divide out. But that happens mostly if we have on the denominator a binomial, all right? Right, becomes the factors of the numerator. The basic thing to do is revise factorization. All right, change of sign rule in a fraction is sometimes necessary for the fraction to be in its simplified form. Right, let's look at the examples. All right, number 1. Determine the derivative of f with respect to x. Now, this would be, if you see there are 3 terms. Each term will have a mark for the derivative, number 1. But if you have to simplify first, then there would be an additional mark for simplification. So this question here might be for 4 marks or for 5 marks. All right? Now, let's check. Here, what we can do is this one is ready to be differentiated. We are not going to differentiate it yet until all the terms are ready. All right, we don't differentiate term by term. All right, we make sure that all the terms are ready, then we differentiate in one step. All right, so let's check. This one is ready. This one, we have a fraction, and we said no fraction. I said in the context of this, the fraction would be when the variable that you should differentiate is on the denominator. So we have to move this to the numerator using what? The inverse law. We know that if we have a b to the n, using the inverse law, this is a times what? B to the negative n. That is the inverse law of exponents, all right? The exponent becomes what? Negative, all right? The exponent becomes negative, and you multiply that with the term in the numerator. Now, let's check. First things first, we applied the inverse law there, all right? The next thing that we did was we actually removed the root, because we said no root signs, all right, no fractions, no brackets. So fortunately with this one, there were no brackets at all right, so this one was sorted. But there were fractions, all right, there were fractions, so we needed to sort them out. There were root signs, we needed to sort them out, all right. Now let's check. Now everything is written in the form ax to the p plus bx to the q plus cx plus minus cx to the r. You see now, and so on and so forth. Now we can be able to use a differentiation, all right? Let's see. Now all of them are ready. We apply the differentiation in all of them, right? One by one. Let's see. We get 3x squared, that is the mark. We get 10x to the negative 3, that is the mark. We get x to the negative 5 over 2, that is the mark. When we differentiate, remember, we multiply, right, the coefficient, and we subtract 1 from the original exponent. So 3x squared, all right, and then negative 2 times negative 5, that gives us 10. Subtracting 1 from negative 2 gives us negative 3. Plus 2 over 3 times negative 3 over 2 gives us negative 1. We subtract 1 from the original negative 3 over 2, we get negative 5 over 2. It's 3 marks for the process there. We will get an additional mark here if it's 4 marks, an additional mark for simplifying and getting it ready. All right, let's go to the next one. There is number 2. All right, number 2, we're going to write it on the next page. All right, let's look at it. Now, if you check here, we said no brackets, no fractions, no root signs, all right? No root signs. Now, if you check, there are root signs, there are fractions, the brackets we are sorted there. So we need to simplify this. But if you check, the numerator is what? A monomial. If the denominator, sorry, not the numerator, if the denominator is a monomial, it's a single term, then you are going to divide each term on the numerator by that monomial. Now, let's see. Converting this back to exponential form, which I said is important, all right? Converting the first one, we get, remember, this was the square root of what? X, which means that here there's a 2, so this would be x to the what? To the half. And then we have the cube root of x. This would be, obviously there's a 1 there, x to the 1 over 3, because the degree of the radical, in this case the degree is 3, is the third radical, all right? So that is what we call the cube root. So the degree is 3, so it becomes the denominator of what? Of the exponent of the expression inside of the square root, if it's a square root, inside of the cube root, if it's a cube root. So that gives us a third. Now we need to divide each term by x, okay? Divide each term by x. When we divide x to the half by x, we get x to the negative half. When we divide x to the third by x, we get x to the negative 2/3. Now it's ready. There are no root signs, there are no brackets, there are no fractions. So we can differentiate. G prime of x, we get this, which is 1 mark. Remember to differentiate. The exponent multiplies the coefficient and 1 is subtracted from the original exponent. So it's 2 marks here, 3, 4 marks there. The third mark goes to the conversion of the root signs, all right? Conversion of the radicals to exponential form, and then the next mark goes to the division by x, and then the last 2 marks goes to the differentiation of each and every term there, all right? Now we can write this with positive exponents, but remember, even if you end there, you are still going to get all the marks, all right? That is rules of differentiation. Okay, now let's deal with the last one in terms of the rules. Let's deal with the last one, or the last one is not animated, it's fine. Now, let's see what happens with the last one. Let me go back. Determine the derivative of the following with respect to x. Now, if you check here, we have y, we have y. So we have to make y the subject. That is the first thing. So you can see here, we transpose those that have y, we put them on one side. Those that do not have y, we put them on one side. Then from there, we took out a common factor of y, which then gives us y into 2x minus 1. We left this as it is. Then we made y the subject. So you can see now the equation is independent of y. It's y equals 2. All right? It's written in terms of x only, rather than here being written in terms of x and y. Now you can see the numerator, it's a cubic, a difference of 2 cubes. The denominator, it's a binomial. If the denominator is a binomial, you can't divide each term on the numerator with that. You'll be complicating the equation. So if the denominator is a binomial, what we need to do then here is to factorize the numerator. Because we have a difference of cubes, we are going to factorize using the method of the method of what? Factorization of what? The difference of 2 cubes that we learned in grade 10. So that is how we factorize that one. So you can see the 2x and the 2x divides out. All right, and then we are left with 4x squared plus 2x plus 1. If we differentiate, we get that it's 8x plus 2. So the first mark here will go to isolating y, all right, making y the subject, factorizing, answer there, differentiate the first one, differentiating the second one, as well as the third one there, but you cannot be given a mark there. Let's see, you can get a mark also for that. 1, 2, 3, 4, 5, 6, 7 might be for 7 marks or for 6 marks, okay? Based on the skill set that is being tested here. So those are rules of differentiation. So now we've done the average gradient, we've done the gradient at a point using first principles, we've done rules of differentiation. We are going to move to the gradient of a tangent and equation of a tangent. Then we're going to get to cubic functions, and then we'll conclude our lesson for today. All right, now let's go to the equation of a tangent. What is a tangent? Is a line that touches the graph at only one point. This is called the point of contact. All right, now we define a tangent, or we're going to determine the tangent as follows. Determine the derivative, which will give you the gradient function, all right, which is the gradient of the tangent at any point. And then we substitute the x-coordinate of the given point to the derivative function to calculate the actual tangent, or the gradient of the tangent. And then we substitute the gradient of the tangent and the coordinate of the given point to the straight line equation, and we write down the equation of the tangent in the form y is equals to mx plus c. All right, now let's look at problems. Determine the equation of the tangent to f of x is equals to x squared plus 2x minus 3 at x is equals to -4. All right, so step one here, we will need to find the point of contact. All right, we have x is equals to -4, which means when x is -4, we need to work out what y is. That would be the point of contact in x and y. Then we need to calculate the gradient. How do we determine the gradient? We use the equation, we differentiate it, that gives us the gradient function. But we are interested at the gradient when x is -4, we will get the actual gradient. Then we have a gradient and a point, we can use the equation of a straight line to find or rather to determine the equation of a tangent. So let's check. Okay. First, we determine the point of contact, just like I indicated. We are going to substitute -4 into the original function, right? And check what we obtain. We obtain 4. So the point of contact is -4 and 4. That's the first thing. And then from there, we are going to write it down. Step 2, we are going to determine the gradient of the tangent. How do we do that? We differentiate, okay? We differentiate f prime of x, which is 2x. This is what? The gradient function. This is the gradient function. So after having the gradient function, we can then substitute the point of the x value of the point of contact to find the actual gradient. So f prime of -4 gives us what? -6. So this is the gradient. So the gradient of the tangent is -6. Now we have the gradient and the point of contact. Then we are going to determine the equation. All right. Y minus y1 is m of x minus x1. Remember, you can use also y equals mx plus c, depending on which one you normally use. All right. So we substitute the point of contact there together with the gradient. And then when we simplify, we get that y is equals to -6x minus 20. So first step, we determine the point of contact. Next, we work out the gradient, then the equation. All right. Hopefully you are still following. All right. Hopefully you are still following. Right. Let's move on. I think I have another example. The graph of f of x is x minus 2x squared. It has a tangent with a gradient of 9. All right. We are given the gradient of a tangent is equals to 9. Calculate the coordinates of the point of contact. Now we have the tangent, and remember, this is the equation. We know if we differentiate the equation, what are we going to get? We are going to get what? The gradient function. Since we get the gradient function and we have the gradient, we can then solve for x first, and then substitute the x back to the original equation to get y, then we would have our point of contact. So first things first, we determine the gradient function. How do we determine the gradient function? We differentiate the original function, all right? Now, f of x is x minus 2x squared. Let us differentiate that one. F prime of x becomes what? 1 minus 4x. This is what we call now here the gradient function. All right, so f prime of x is our gradient function. However, we know what the gradient is. The gradient is what? Is 9. So where we see f prime of x, we can put what? 9. So we equate the gradient to the gradient function. You see, 1 minus 4x. Here where I see f of x, I put what? 9. And then we solve for x. Negative 4x is 8. I transposed the 1. X is equals to negative 2. Now we have the x value of the point of contact. We take it back to the original equation to get what? To the original function to get the y value of the point of contact. Next, we substitute the x value to determine the corresponding y value. Let's see. Y is equals to f of negative 2. When we substitute the x value on the original, where we see x, we put negative 2. All right, so negative 2 and negative 2 into negative 2 all squared. And then we get y is equals to negative 10. Then the point of contact is negative 2 and negative 10. All right, that is the equation of a tangent to a curve. This is a different type of question. You are working backwards, okay? You are working backwards as opposed to the one that we started with. All right, now I want us to use the remaining time to look at the graph of a cubic function. All right, the graph of a cubic function. It will be there tomorrow. All right, either sketching or interpretation. So you have to prepare for both. All right. The cubic function is the graph of the form f of x is ax cubed plus bx squared plus cx plus d. A cubic function can have up to 2 stationary points, but all cubic functions would have 1 point of inflection. There are 3 possible shapes. Remember, the shape depends on how many stationary points you have. If you have 2 stationary points, that would be for a is greater than 0, right? That would be the first shape. If you have 1 stationary point, which is the point of inflection, that would be the function, the shape of the function. If you have no stationary point, like for an example, if you have, let's say, y is equals to x cubed, like that. All right, and then from there, there's no stationary point, so you get the curve to look like that. All right, where it will only have that point of inflection. All right, now if a is negative, 2 stationary points gives you this shape, 1 stationary point gives you this shape, and no stationary point gives you that shape. So the shape, the actual shape, depends on the number of stationary points. That is why when we are asked to sketch a cubic function, in the first step, we determine what? The stationary points, so that we can know how many they are, and hence they can inform us how the shape would look like. All right, because the shape depends on the number of stationary points. All right, now step 1, we are going to determine, if we want to sketch a cubic function, the number or the coordinates of the stationary point by letting f prime of x to be equals to 0. We solve for x, we substitute back to get the corresponding values of y. Step 2, we consider the sign and determine the general shape. It's now that you're going to look at A and the number of stationary points to get the actual shape. And then we determine the x and y intercept by putting x to be 0 and y, by putting y to be 0 and x to be 0 respectively. And then from there, if asked to determine the coordinates of the point of inflection, we are going to let f double prime of x to be equals to 0, and we substitute back the value of x that we've solved for to get the corresponding value of y. Then we can plot our smooth curve. Okay, now when determining the equation, now we are going back, we are reversing the cubic function. We want to determine its equation. When determining the equation, it depends on what you are given. If you are given 3x intercepts and a point, this is what you are going to have. Okay, this is the first x-intercept, the second one, the third one. We are going to use y is equals to a x minus x1, x minus x2, and x minus x3, where x1, x2, and x3 represents what? The x-intercept. And then xy represents the additional point. Then we can multiply out to get to this space. All right, that is the first case, given 3x-intercept and an additional point. Now, the second case, given two x-intercepts, x1 and x2, all right, where the other one is also a stationary point, all right? So in that case, this is what you have. You see x1 is tangential to that, so it is the repeated root, all right? So we'll use y is equals to a into x minus x1 squared, x minus x2, where x1, here x1 represents what? It represents the one, the x value, that is also that forms a tangent with the x-axis. All right, that forms a tangent with the x-axis. So in this case, it will be x1. That is the repeated root. And then from there, you follow the same process. You substitute that. And then from there, you substitute the additional point. You FOIL out. You get the original equation. Then number 3, this is the one that is a bit more complex. When we are given the stationary point. All right? 2 stationary points or 1 stationary point. What we do is to determine the equation of that, we are going to act like we are determining the stationary point. How do you determine the stationary point? You differentiate and you equate the derivative to 0. Then from there we can substitute the x values of the stationary point to generate the equations. Here we use simultaneous equations, okay? So what we need to note is that the stationary point plays a dual role, right? It is a point where the gradient is equal to 0, right? It is also a point on the graph of f. So it can be substituted onto the original function. It can also be substituted onto what? The derivative, because it plays a dual role there, all right? Let's now check the examples on the equation of a cubic function. Checking the first one, you can see we are given x-intercepts x1, x2, x3, and then we are given an additional point 0 and -8. So because we are given 3 x-intercepts and a point, we are going to use the case 1 approach, all right? So let's see. Y is equals to a into x minus x1, x minus x2, x minus x3. Substituting the x-intercepts, all right? x1 is -2. So substituting it here gives us negative of -2, that is +2. x2 is -1. Substituting it there, it's negative into -1, which is +1. And then x3 is 4. Substituting 4 there, we get x minus 4. Now, next thing that we need to do is we substitute a point 0 and 8. Where we see x, we put 0. Where we see y, we put -8. From here, we can solve for x. 0 plus 2 is 2. 0 plus 1 is 1. 0 minus 4 is -4. So we get that 2 times 1 times -4 is -8 times a is -8a, Dividing both sides by -8 gives us a is equals to 1. Now that we have the value of a, we can always come back and substitute it there, and then we'll FOIL out. Substituting a there, we get that. Then we can FOIL out. Now, how do we do that? Let's start with this bracket. X squared minus 4x plus x minus 4. So minus 4x plus x gives us minus 3x. So we are done with the last two brackets, right? We made it quadratic by applying the distributive property. Now we can distribute the first bracket here, all right? Starting here like that. And then with 2 like that, all right? When we distribute like that, this is what we get. X cubed minus 3x squared minus 4x plus 2x squared minus 6x minus 8. Simplifying that, we get f of x is x cubed minus x squared minus 10x minus 8, all right? So that is the first one that we have actually worked out. It aligns itself with what? With case 1. Now, looking at the next one, this one you can see it aligns itself with what? Case 2. x1, x2, and then from there, turning point at that. And then if you check here, they have given us the value of a. A is equals to -1. So there is no need to recalculate the value of a. We have it. So we need to be strategic here. The solution, look at this now. A, x minus x1, x minus x2 squared, because x2 is the one that is tangential to the x-axis. So it is the repeated root. All right. So now we substitute. We already know a is -1. We substitute a as -1. And then from there, we leave out the x values there as they are. We are going to then simplify x minus 1, x plus 3, x minus 2, all squared, all right? So when we simplify that one, you can see that we can actually FOIL out the second bracket, okay? When we FOIL out the second bracket, we get x squared minus 4x plus 4, all right? Because it's from x minus 2, which is x squared minus 2x, x squared minus 2x plus 4. So this gives us minus 4x that we have there. And then from there, we can actually FOIL everything out, all right, leaving out the negative. And then after that, we distribute the negative. We get x cubed plus x squared plus 8x minus 12, which means that we will be done with that one, all right? So that is aligning itself with what? With case 2. Now there is one that aligns itself with what? With case 3 that we need to look at. This one, we are given the 2 turning points, all right? The 2 turning points and an additional point. If you look at this point here, is the additional point. It passes through the origin, 0 and 0. Now, also here you can see we are given the value of a, which is -1. Now let's go about it here. Remember, h of x is -x squared plus ax plus b. Since we are given the turning point, we will differentiate, because that's how we determine the turning point. So we differentiate, all right, first things, and then from there we equate the derivative to 0. But first here what we did was, after having differentiated, we substituted x is equals to what? -1. H prime of -1, we generate an equation here, all right? We are generating an equation because the derivative is equals to 0, right? Remember, h prime of x is equals to 0 at what? At the turning point. So we equate it to 0, we've substituted 1 there, all right? So we then generate an equation. We get that b is equals to 2a plus 3. That is equation 1. Now, we do the same thing for the next point 2 and 10. So we get h prime of 2. This is the turning point, or rather, this is the value of the gradient when x is equals to 2. But we know the gradient is equals to 0 at this particular point. So we equate that to 0. We generate another equation. We get that b is equals to 12 minus 4a. Now we have equation 1 and equation 2. We can solve them simultaneously. By substituting 1 into 2, we get 2a plus 3 is equals to 12 minus 4a. And then from there, 6a is equals to 9. Okay? And then a is equals to 3 over 2. That is the value of a. How do we get b? We substitute a in one of the equations. Okay? Now, if we substitute a in either 1 or 2, that is what we get there. We get b is equals to 6. We get b is equals to 6. All right? Then we can write down the equation. So h of x is negative x cubed plus 3 over 2 x squared plus 6x. So what we basically did here was, because we were given the turning point, we have to solve f prime of x is equals to 0 for this one, and also h prime of x is equals to 0 for that. This gives us equation 2. This one gave us equation 1. Then we solve the two simultaneously. Okay, so that is how you do it for case 3. All right. Now, the last question is about the graph of the derivative of a cubic function. The graph of a derivative of a cubic function. In the sketch below, the graph y is equals to ax squared plus bx plus c represents the derivative f prime of f, where f is a cubic function. Write down the x-coordinate of the stationary point of f. Write down the x-coordinate of the point of inflection of f, for which values of x is f increasing, at which value of x does f have a local minimum. Explain. Hence or otherwise, draw the graph of f. All right? Let's go through that. First one, write down the x-coordinate of the stationary point. The x-coordinate of the stationary point are these values there. Because remember, the x-intercept of the derivative function represents what? It represents the x values of the stationary point of the original function. So we get that is 1 and 2. So that is 2 marks. All right? And then from there, the x-coordinate of the point of inflection. Remember, the point of inflection of a cubic function, when you have a derivative function, it is the axis of symmetry of the derivative function. So we work out the axis of symmetry using the midpoint, because we have x at the midpoint should be equals to what? x1 plus x2 divided by 2, which would be 1 plus 2 divided by 2. So that would be the midpoint, all right, which would be 3 over 2. That midpoint represents what? It represents the x value of the point of inflection of the original function. There we go there, all right. So we deal with the substitution there and the value of x there for 2 marks, all right. And then for which values of x is f, the f is the original function. For which values of x is f increasing. So f is increasing if the gradient is positive, all right? F is increasing if the gradient is positive. And this is the gradient function. Where is it positive? Above the x-axis. So this portion of the graph and this portion of the graph represents what? It represents where we have a positive gradient, and that is where the original function is increasing. So it increases when x is less than 1 or when x is greater than 2. All right? Now, we have these 2 points. They want to know which one of these 2 points. Here you get a mark here and a mark there. It's also 2 marks. Now, we want to know which of these 2 points represents what? The local minimum. So to do that, we can use the first derivative test, or we can use the second derivative test, all right? Or we can just use the nature of this to give us the original shape of the cubic, then it will tell us which one is a local minimum. So here I'll use the first derivative test. If I'm using the first derivative test, I am going to test the stationary point on the left, all right? Test the gradient on the left because the first derivative is the gradient. Test the gradient on the left, test the gradient at the stationary point, test the gradient just on the right hand side of the stationary point. So you can see here, but that is the first derivative test. By second derivative test, what we do is, by second derivative test, you go to the actual stationary point and check the gradient of the gradient. Is it having a positive gradient or a negative gradient? Then you use concavity. I think that is what I used here. So the second derivative test, f double prime of x is greater than 0. If you check the gradient when x is equals to 2 is positive. Therefore, f is concave up. Remember, we are saying when f double prime of x is positive, we have what? Concave up. And this is concave up, which means that this becomes what? A local minimum when x is equals to 2. So you will get, if it's 2 marks, you get your 2 marks there for picking up that it becomes concave up, and hence it will have a local minimum when x is equals to 2. All right. Now, last but not least, how do we sketch this cubic function? Now, I want you to focus on this. It's not difficult to sketch this cubic function, but look at what we are going to check. Check the shape of the quadratic. The shape of this parabola is concave up. And we know for it to be concave up, it means that a was greater than 0. So a is greater than 0 for what? For f prime, right? Which means a will be greater than 0, which means a will be greater than 0 for what? For f. And if a is greater than 0 for f, what do you obtain? You obtain this shape. All right? This is the shape that you obtain. And then from there, the one that is on the left would be the first stationary point on the left, which is 1. The one that is on the right would be the second stationary point, which is 2. All right. So you are sketching. This is the rough sketch. It does not have any y values. So you are going to get 3 marks for this. 1 mark for the shape, 1 mark for the stationary point, number 1, 1 mark for the stationary point, number 2. So you get 3 marks here for your trouble, for being able to sketch this cubic function. All right. So remember, good people, practice, practice, practice. You still have time. It's never too late until you write the paper. All right. Let's preview our next lesson. Our next lesson is tomorrow. All right. The 5th of September from 2:30 to 4:30. All right. We will be doing paper 2 revision, but the focus will be on analytical geometry and trigonometry. So tomorrow, after you've written your paper 1, please just rest a bit, all right, because you'll finish writing at 12. Just go home and rest a bit. And then from there, those that will remain at school, rest there at school. Make sure that you refresh and you get ready to meet us at 2:30 to 4:30. We'll be taking you through the revision for paper 2, all right? Please take care of yourselves. Take care of each other. Practice mathematics. Goodbye.